All right, so what do you think happens for when instead of 0.3, I do 0.25? What do you think should happen to the average?
I think that range is when we really saw a big change start to happen. So I think there's going to be the mean is going to be a lot less because it'll be such a dramatic change.
All right, what do you think?
It should be significantly less, even though it's such a small change. So maybe we're like around 0.5 or 0.4.
Okay, so here's what the graph looks like, and here's the histogram.
It's even lower than I thought.
Hold on one second. Yeah, 0.25. Yeah, so here's the histogram. Let's just focus on the histogram.
Well, it seems like there's a lot more variance. It seems the graph is more spread out than the previous one, which just sort of peaked, or actually at point
Yeah, I can
8
bring
actually.
Yeah, so here, almost all the time, things spread very far through the network. It was only in rare occasions where they didn't. But at 0.25, now, it doesn't usually even get all the way through the network.
Mm-hmm.
But still, what would you say about this distribution?
I mean, like, still, you only have like roughly maybe a quarter of the people on average get infected, but like you wouldn't be surprised to see like 40% get infected or even like 15%.
Mm-hmm.
And there's like this weird low bar at 0.2, but that's probably just an anomaly.
Yeah, I mean, I bet if I did 10,000 runs instead of 1,000 runs, it also could be just based on the choice of number of bars I made for the histogram. So if I had a disease like this, sometime, even if I knew all the parameters exactly, sometimes I might only get 15% of the population getting it, and sometimes I might get 50% of the population getting it, and it's just by random luck.
That's a big difference.
All right, so what do you think happens when we go to 0.2?
I think it should maybe spread out and flatten even further, but it still should have a smaller mean. Maybe it'll just might be a smaller graph,
Right,
maybe a wider graph.
I think it'll actually condense inward, and the mean it'll be shifted over more than 0.3. I think it'll be a little bit farther this way.
All right, let's take a look. Here we go.
So
It's much smaller, actually.
this is only at 0.04. So, I mean, if we looked at this on the same scale as the previous ones, it would be really, really close together.
Yeah.
So there's not a lot of variation here. You wouldn't really expect to see this infect much of the population.
Right, and so here what we're seeing in these distributions is what we saw in the graphs a little bit today and a lot last week. There's this almost step between when people are only meeting 0.2 people on average, the infection hardly spreads. At 0.3, it basically goes through the whole network almost all the time.
Mm-hmm.
And that's such a small change, it's really surprising. Anything else you want to say about this?
No, not really. It's sort of what I expected, though.
All right, so if I had a random virus where I knew it had this characteristic, what would you expect to happen on multiple infections on different times that virus hit?
It should be, the impact should be very similar to the different cases.
Yeah.
It shouldn't be that spread out.
Okay, cool. Now what we're going to do is we're going to look at the 0.25 case, but we're going to vary the initial infections.
Okay.
All right.